Welcome back, third hour geometry. Andrew, if you are watching this video, at some point I'm going to tell you what my favorite number and color are, and I want you to tell me when you come back to class for a prize. Cool. Some point in this video, watch the whole video. You'll hear me say it. I'll make it very clear. It'll be obvious. Sweet. All right. If he doesn't say anything, you guys have to remind me when I get a bag of candy in here that I owe you candy. Cool. All right, so today we are continuing on, and we're just going to jump right in. We talked about a trapezoid yesterday that has exactly two sides, or one pair of sides parallel, and that's it. Now, this trapezoid, what is annoying about it? What's wrong with my trapezoid? Okay, we're going to completely switch something real quick, because I had to do it first hour also, and in a lot of classes. I'm not going to make anybody say it right off the bat. How many of you think you have an idea, like in your head, you just don't want to say it in front of everybody for whatever reason? If I say, what don't you like about this? How many of you have something that you don't like about it? And you could probably explain it, but you don't really want to explain it in front of everybody. Most of you probably can tell me what it is that's annoying about this. Here's the new kind of standard that we're going to work. When I ask a question out to everybody, instead of just waiting in silence until I have to pick somebody random, which we'll keep doing if necessary. Carson might have zoned out for a second. Just kidding, he's back. Holy whiteout. When I ask a broad, open question like that, immediately in my head, a 15-second timer starts. That's your chance. I want you to turn and talk. Like, physically speak and communicate, and then I'll just call on somebody random and say, what did your partner say? That way, you don't have to speak for yourself, but I also don't want it to just be awkward silence. We're all waiting. Everybody understand that? So check it out. What is weird about this trapezoid? 15, go. What's weird about it? If you need to move so you can talk to somebody, you can. Or if you're comfortable talking with them.
Or how long is one leg slanted?
Why? It's not the trapezoid that I was raised with, right? Like, things are different, right? That's not really what you said. But is it the bases that bother you, or is it the legs? One leg? One leg bothers you. Clearly, it's this one that bothers you, right? Probably not. Which leg? Why does this bother you? Help me out. I'm going to draw it. I'm going to probably draw it the right way. And I'm going to switch colors for it. So if I wanted the bases, we'll just do it naturally. Do you want the bottom base bigger or the top base bigger? Bottom. Wider on bottom? So if I'm going to draw it, let's say here it is, and we'll draw it this wide. And what do you want me to do at the top? And I'm actually going to make it mine giant so I can draw it like nice to scale. Smaller? And it doesn't matter how much smaller. Does that seem okay to you? And they're parallel. So these are my bases, right? So base down here and a base down here, or up here rather. And it's weird to say there's a base on top, but it's allowed. And then now we'll draw my legs. And there's something that shakes out of this that's really nice. Why is this trapezoid better? It's more aesthetically pleasing, maybe. Did I draw what you might consider an isosceles trapezoid? So there's a few ways you can think about it. What Carson is recognizing is he said the base angles. He didn't say exactly that, but that's what he was implying. These angles seem to match now, right? What about the lengths of them? Are my legs the same length? So for an isosceles trapezoid, we're just going to be really concise, which is just short writing. 2 congruent legs. That's what makes it an isosceles. Now, from this isosceles, Carson, you already picked out one of the parts of it that I was really hoping to hear, so kudos for that. There's there are some special things that are going to happen here. Right off the bat, Carson, I love what you said. We're going to sneak 2 theorems right here, and we're going to write it fairly short because we spent so much more extra time. If I have swung the opposite way too far, and now I'm going way too fast, what are you going to do, Raylene? Good. Preferably not just sit there quietly and then struggle with it. Ask, right? Open communication. All right, so here we go. First theorem, Carson, you made an observation a second ago that was, I just want to highlight again, it was awesome. This is actually theorem 6.4, and these are both trapezoid theorems. They don't get their own names, but I'll do them in different colors. So if you give me, what sort of trapezoid does this theorem apply to? Isosceles. Theorem 6.4, I'm going to give it a name. We're going to say base angles. And we can write if and write it in words. We can do the implies arrow. Do you guys have a preference whether it says if and then, or can I just do the arrows? Arrows. So check it out. If you have an isosceles, and I'm going to suggest this for our shorthand, isos, trapezoid. Then, and Teodi, just so you know, and I'll wait till you catch up, there's a whole lot of things up here on the board. Have you ever seen most of these symbols? And that's okay. They are very specific to the world of mathematics. We won't use all of them, and we probably will, but this one, have you heard of if-then statements? So I think real quickly, we're just going to take a side trip. If you mouth off to your parents, then what happens? You get, I didn't hear what you said, grounded, in trouble, something? Like there's an obvious implication, right? Like this is what happens. This symbol, the double arrow like this, it just means then or implies. So when we read this, it says if it's an isosceles trapezoid, then what do we know about those angles, Carson? Base angles congruent. Now, base angles congruent. What I think would be helpful is on this trapezoid, let's give it a name real quick, and it doesn't have to be trap. Anybody have a preferred name for this thing? Ooh, I want to see how closely you listen. What's my next kid going to be named? Oh, you're good. It almost sounds like I'm saying Kyle Holloway really fast, which is, don't tell that to Mrs. Holloway because she hasn't noticed that yet, I don't think. But let's say that this trapezoid is Kawe without the accent. Which, when I say the base angles are congruent, it's just nice to have on this picture. E.g., exempli gratia in Latin says, hey, look, here's this demonstrated. Vincent, what's one of my base angle pairs that are congruent? Angle what and what? One more time. So I heard you say like 5 things, but I didn't quite actually hear it. K and E? Angle K is a base angle for sure, and angle E is a base angle that has the same measure. I agree. Is it just that, though? Could you convince me that the other base angles, A and U, are congruent? They certainly look like it, don't they? Now, whether you can convince me or not as big of a concern for me. They are. Both pairs of base angles wind up congruent in this situation. All right. You do not have to draw this, not on yours, but we're going to take like a 2-minute or so. We're going to chat with one another. Wonderful outside. I'll step outside real quick to grab something here in just a moment while you guys have your 2 minutes. I'm going to draw one line. And typically with theorems, you're given a big leap of faith, right? Now, I hope you guys all trust that I'm not up here just lying to you intentionally to teach you the wrong math so that you struggle for the rest of your life. Not what I'm doing. I don't think anybody thinks that. But I also don't want you to just say, oh, Holloway said it must be true, because I do make mistakes. What's a good thing that we should probably do that elevates this from just some random statement to a theorem? Prove it. Now, I don't need you to write a 2-column proof, but for real, I am going to step outside. I wasn't joking. I'm going to add one line to this. I want you guys to try to convince me somehow, if I were to draw these lines, and whether you draw them on yours or not is up to you. If I draw these 2 lines on there, could you convince me that K and E are the same? I'm going to give you a moment, 2 minutes. I want you to talk with your neighbors. You don't have to write a 2-column proof. I just want the logic. How could you possibly convince me that K, and I don't know why I didn't mark E, how could you convince me that those are the same just by adding those lines? Okay, 2 minutes, roughly starting now. If we just use this, everywhere equidistant, perpendicular, and congruent, then we're there. My favorite color is dark green. 100%. It is dark like forest green. Not teal, dark green. Okay. Dark green is my favorite color, Carson. Okay. Beyond that, we can just show hypotenuse leg and we're there. Now, additionally, I have one more question about these, and I'm just going to erase all this other stuff. Carson, we use hypotenuse leg is what we use here, just so you know. Everywhere equidistant, so we know that this distance is the same as this distance, and then we have a hypotenuse and a leg of this triangle. If they're the same, corresponding parts are the same. That's how we can get this proof. Now, if we added one more, and you don't have to sketch it, because I will. I'll sketch a nice isosceles trapezoid here again. A little bit different size, a little tiny bit different. Are there diagonals on this? Like, I haven't drawn them, but could we draw them? So I think we could. That diagonal and that diagonal. Well, any gut feeling about those diagonals? So shot in the dark, 30 seconds, talk with your neighbors. I don't care if it's wrong. I just want to hear, what do you think might be true? And we can name these. Well, I'm Kyle. What do you think might be true about KL and Yi? YE or AEY? What was yours? So maybe they bisect each other. That could be true. Anytime I hear an idea that I'm not sure about, I'm just going to try to make it like really obnoxious so I can see that if that's true or not. So typically what I'll do is I'll just draw a really dumb looking trapezoid, and it typically, like normally this will help. Do they bisect each other, you think? So like I can tell very clearly that that's not the same. This one certainly looks like it, and that's a reasonable thought, so good. But if we can find a counterexample, it doesn't work. So they don't bisect each other because we just showed that it wouldn't be true on a really big one. Anything else that might be true? I don't think they bisect the angles at the bottom. It doesn't look like it there. Huh. What if we just look at one of them? If we look at one of them, okay, we're just gonna have to erase it. If we look at just one diagonal, it cuts my trapezoid into two triangles, right? What do you think is probably true about those triangles? You think they're congruent? Why? So I'll even put the mark there and there. That one's the same too. Side, side, side. Now, if we look at it, are you sure? Does this top length show up anywhere on the bottom one? Maybe it does, and we just don't see it. Okay, so for this, I think it's reasonable to think they're the same. Now, this one, I'm just going to spoil it in the interest of time rather than like making you guys come up with this whole idea of mathematics. It's always existed and people have spent a lot of time on. But I'm going to write the theorem, and you guys tell me if you think we could make this true. So one more theorem real quick is 6.5. And this is about the diagonals of this bad boy. Diagonals of trapezoid. And it's the diagonals of an isosceles trapezoid specifically. Okay, love what Camille recommended. Wasn't true in the end, but that's okay. That's part of mathematics. As we're looking at it, the diagonals of isosceles trapezoids. If isosceles trapezoid, and I don't need the if part, so we'll just say, you give me an isosceles trapezoid, then the diagonals of that trapezoid are congruent. Which means in this picture that we just drew, and if you have this one, I would use these names for the segments. If you have only this one, I would use these names for those diagonals. If we're using this one, EG for this, on that top trapezoid, AE, Carson, that segment, AE, ought to be congruent to what? Yep. AE. So segment AE should be congruent to Cool. All right. Awesome. We have it. Do you think you can convince me that this is true? And not even, again, I'm not asking you right now to convince me it's true, but what approach might we use? I do think that those other triangles, the ones that we pointed out earlier, I do think that they're going to wind up being congruent. If we have both diagonals, are there any other that you think might be congruent? So the top and bottom one, I don't think will be. And right there, it does look like it. But again, I think that's just an artifact. If I draw this really obnoxiously, like this, do you still think the top and bottom ones are? No, but that's okay. Did this picture maybe reemphasize that another pair could be? I think these ones are going to be. So if we could show that these are the same, then we could show that that piece corresponds to that piece, and that that piece corresponds to that piece, and then the angle addition does wind up adding up. And it should be like this. It should be that. Those are the same, and those are the same. Cool. We would just need to show those triangles congruent, and then we use segment addition to make the whole diagonal. Okay, looking at those, let's do a trapezoid problem. So we're here. Should we take a really quick brain break? Okay. Well, looking at this, Lily, I'm going to encourage you to zone out during first hour when we do it because you're going to get the same thing every single day. You may not remember. Before or while I'm getting this set up, I'll pause the video in just a second. I just really wanted to make sure that you guys are aware I have two favorite numbers, it turns out. My first favorite number is 7. Don't know why. It's a pretty common favorite number for people. 7, it's a prime. I don't know, that's kind of cool. But I also like 21. I do not like even numbers, and I don't know why. Not a fan. 21 and 7 are my favorite numbers, and green is my favorite color. Cool. All right, so let's knock one out, little editing magic. Our example is we, on this problem, are going to try to find the length of a part of a trapezoid. So let's see which one we want. I want us to do a couple things here, and I want to get crazy with it. Let's see how challenging we can make it. Wild. So here we go. I want us to find diagonals, both lengths. And we're nearly done with this. Find diagonals here. And just one of these examples for now. We are going to have this lovely isosceles trapezoid. We'll call it AB, CD. And that doesn't quite look right to me, so it has to go to there. There we go. Bottom left is A, and then we'll work around clockwise, B, C, D. We'll mark it as isosceles. So an isosceles trapezoid is present right now, and I'm going to draw in the diagonals, AC and BD. We are trying to find AC and BD, but I'm going to give you some more information. Additionally, we are told that BD is exactly equal to 9x minus 3, and that AC is equal to 7x plus 5. I want you guys working together. We're going to try to shift a bit of it so it's not just you listening to me talk the whole time. I want you guys, about 90 seconds, talk with your neighbors. Let's see if we can figure this out. I think we'll be able to. I would keep the theorems in front of you for a moment. While you're doing that, I'm going to get another one set up that we'll talk about. Cool. Go, 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 go. Like, that's the whole thing, right? It's just immediately use. Yeah, I don't believe you. They should be equal. I think this is how people start. You guys did this, right?
Yeah.
Okay. What do you want me to subtract from each side? So add 3 to each side. I'm fine with that. I'm going to do 2 steps in 1. I'm also going to subtract what? 7x. So I'm just doing 2 steps in 1, but we'll write them both. I wind up with 2x equals 8, and x is 4. And when we did this, I had several people say, wait a second, something doesn't work, but let's try something. What's 9 times 4?
36.
Minus 3.
30.
So BD, we just found, was 33. And unless the universe has all of a sudden changed the rules of mathematics, when I plug this in, what should I get for AC? And I want to see that we do. and I want to know what your mistake was. What's 7 times 4? 28 plus 5? Okay. I found Lily's mistake just now. What were the other mistakes? Carson, what was yours?
I did 7 times 3.
Interesting. So that feels like more like a typo. Lily did 7 times 4 is 26. Easy mistake as well.
I did 9 times 4 was 28.
Equal easy mistake. Fair. Okay. Ashley, did you get this answer? Okay. Can you tell me your answer in your best Russian accent? Do you guys do accents? Do you want to learn? Do you guys do any accents? What accent do you do? Is it Filipino? Because that one doesn't count. Okay. So there's some that I can't do, and there's some that I won't do just because of the fact that I'm kind of pale. I cannot do a Brazilian one. I don't know why. I've spent a lot of time around Brazilian people. I don't know. Can't do it.
Your best one.
I think my best one's probably Australian because that's where I was born. But it might be like Alberta, like Northern Canada, because that's where I was born. So I don't know. Looking at stuff, Irish is also kind of fun because check this. I was born there. I don't know. Probably Australian. Can you guys do an Australian accent? I can't do an English accent anymore because the Australian just takes over. Kiwi accents are super fun as well, which is pretty much Australian, but the vowel sounds change. That's New Zealand. Okay, I want you guys to say good. And I'm pointing at a what? I'm poking my eye. Good eye. All right, how's it going there? Right, we're just going to talk about it like we're coming in from Adelaide. We might have flown in from Melbourne. We came from a lot of places over the years, but we're here now. We're doing some mathematics. Let's jump right in. Yeah, you just say your vowels with a bit more weight behind them. You let the, instead of behind, it's almost like an OI noise that you make. Oh my gosh, like you just let it ride right out of your mouth, yeah? All right, now if you want to take that accent and just switch it just a skosh, just a little tiny bit, make it sound a bit more like you're a Kiwi, means you're coming from the island, a couple hundred miles away. They're not really Australian anymore. But all you got to do is just take some of the vowel sounds and you make them a bit different. So, for example, if I go to the restaurant today, I might go and get some chips, right? You might have some chips with your dinner tonight, maybe. Not in New Zealand, you wouldn't. The I sound, instead of that comes in English like we normally talk about it, it comes out as an sound. So if I ask for a bag of chips here in Australia, no problem, right? Everybody knows bag of chips. But if I go across the bay over here, we wind up in Christchurch, wherever we might be, I have to go to the store and I look, hey, brew, can I get a bag of chips? It's no longer chip. We turn it chop. Oh, hey, brew. That's me saying, hey, bro, how you doing? Not bad, great. Oh, hey, brew, what do you think about that? Their vowel sounds, they change. No, now it's getting weird because they're trying to mix together. Cool. Super fun. We should all pick an accent just to work on. Well, I came in today. You can talk really slow. You sound like you're an old man who might have grown up and spent a bit of time in the outback when he was younger. Can't tell you how many dingoes I've had to fight in my day. The Aborigines, they've been living around my place, accepted me into their tribe. I married 2 or 3 of them years ago. Cool. Really easy. We should just make it up. Irish is pretty similar. For the Irish accent, you just got to let your vowels come out a bit faster than they normally would. You just talk like you're from northern part of the Isle, yeah? So you're coming from Dublin, you came in from Glasgow. I don't know where you might have come from over all these years, but you just stretch out your vowels just a little bit. They start to sound like they might be, I wouldn't quite put them in England, right? Because that wouldn't make much sense if we're talking about England. We're in Ireland. They're 2 different countries. People don't always recognize that. We're going to work on accents in here. Can everybody say, okay, sure, okay. No problem there, Holloway. You got it. Now, I assume that there's probably one of them hiding in here that might be real. Who knows? All right, one more theorem.
Try and learn Liverpool.
They're heavy. The Scottish is also a hard one. Right. I can't do it. All right, one more theorem. And I don't think we're going to do an example of this. We're going to try just to present the theorem and say, I want you guys to be able to apply this theorem. Last one. Do trapezoids have sides on them? In fact, they have how many sides? 4. And each of those sides have a length, I assume. They have to. It's a side. We get one more theorem where we're going to sneak a word. Last theorem of the day. Theorem. It's the 6th one of this chapter already. 6.6. And we're going to call this the trapezoid, trap for short, mid-segment. And I'm going to sneak that in as a definition here. The trapezoid mid-segment theorem. Okay. Have we seen a word this year that has mid in it? What is that word? Midpoint. Do the legs of a trapezoid both have midpoints? This mid-segment, it connects the midpoints of the legs. That's it. If you give me a trapezoid, this is connect or connects midpoints of the legs. And we'll get a picture of this as well. And here we go. We're going to draw the picture right away because it's going to help us make sense of it. I'm going to draw a straight line first. So here's a lovely trapezoid, 3 over and down, and boom. Okay. So looking at this, I know that the midpoint is going to live right here and right here. And I'm not really just eyeballing it, but it doesn't have to be perfect. Let's name this midpoint. Let's see. We're going to say bottom left is K, the top left is A, the top right is R, the bottom right is S, the left midpoint is O, and the right midpoint is N. Hey, look at that. Just for you, man. Okay, I want to draw the mid-segment. And I suppose I should probably specify here. O and N, they're special. What are they? They're the midpoints. So I need to make sure that that and that are the same. And then if this is an isosceles trapezoid, which whether it is or isn't, I'm not going to make it be such. As long as these are the midpoints, I'm cool with it. Does not have to be isosceles. We drew an isosceles, not required. Okay, if I draw this mid-segment right here, and we'll even write it, and I'll write it, you don't have to. This segment, ON, is my mid-segment. Okay, the mid-segment, do you think the length of it relates to the legs of my trapezoid or to the bases? Which one is it parallel to, the legs or the bases? It's parallel to the bases, so it is going to relate to these bases in some way. Here is our theorem. If we have a mid-segment for any trapezoid, so here we go, the mid-segment, and I don't know why I start with a parenthesis here, the mid-segment of any trapezoid, whether it's isosceles or not, doesn't matter, is, and we have 2 statements to make. The first of these statements is that first one that I just kind of said was just allowed to say. The mid-segment is, first off, parallel to the bases. But additionally, we know something crazy about the length of that mid-segment also. If you wanted to take the length of this, it's longer than one of the bases and shorter than the other. Always the case, right? Turns out there's a very special relationship. In this case, the length of a mid-segment is equal to 1/2 the sum of the bases. Now, just to get that EG in here, and then your homework tonight is going to be pretty much all at home. Sorry, I don't know how this wound up taking so long. Did today feel super slow too? It didn't feel wildly slow, but we did a bunch of random stuff in the process, so I'm cool with that. Okay, for this, in this picture, what that means is right off the bat, this one, ON, is parallel to what?
AR.
AR and and I'm going to write it again whether you do or not, ON is also parallel to KS. It's going to be the case. Has to be. Additionally, though, the other part of it, that's this parallel part. The other part of this is that if I wanted to talk about the length of ON, it's 1/2 the length of what two pieces do I have to add up? What's one of the two bases? AR plus, what's the other base? KS. Boom. This one we will not prove right now. Later in the year we will. Okay, tonight, just a reminder, how long should you spend on homework? 40 minutes outside. I'm going to say homework 6.2. Does this section feel hard or easy? Okay. I want you guys to do 14 through 20. You will find this waiting for you on page 264. Sorry. All right, CAL, see you later. Do not tell Andrew to not watch the video. I hope he watches it. Just as a reminder, who's the coolest person that you've had the pleasure of speaking with today? Mr. Holloway, I heard with confidence. Love it. Cool. Smash that like button, subscribe, comment down below to let me know what you think about the video. Check out my Patreon. Peace.